So sleepy. I just want to go to sleep.
You should go home.
I wish. I really wish you can go home and sleep. I don't know why I'm so sleepy. Before I was coming here, I was in my office, and then I was like, "Oh, it's so warm." Like I have my tiny heater on, and it was so warm.
Heater?
Yeah.
Is it that cold in the math department?
If you stay for a while, it becomes so cold.
It's like here, it gets
If you stay for a few minutes, it's normal. But if you stay for like 2 hours, 1 hour, it becomes cold.
So it's that cold.
Yeah. For me, it's always cold. So I have my small tiny heater in there. Okay, anyway, I want to remind you about your two things. One is your next exam is this Thursday, and the other thing is the authenticator thingy. The
that's it. Yeah.
what do you call that? Multi-factor authentication. I hate that. So without that, you cannot log into your Brightspace or CUNY first. You have to get that done from 14. Well, 14 is already done, right? It's 21. So do you guys already started that using? Yeah. For us, it just started from 7th or something. But for students, yeah, so CUNY moved to multi-factor authenticator verification thingy. All you have to do is download authenticator app in your iPhone or in your phone or tablet. So if you have newer version of the phone, you can use Microsoft Authenticator. You can download that. But if you have older version where Microsoft Authenticator doesn't get downloaded, it doesn't support. So you can use Google Authenticator. Okay. So download that app and then follow the steps. They send you in an email. You have to go to some website and then with your phone, click the barcode, and then it will tell you what to do. And if you don't know what to do, just go to the PCTC. It's on Library Building, 6th floor. Okay? But make sure you get it done, otherwise you cannot access the Brightspace anymore. And also the CUNY first. Okay, so in our last class, we did not record anything because it was only 1 hour class. So my point is to go over the materials real quick in 5 or 10 minutes. The materials, what you learned last class, and then we'll start the new materials. Okay? Any question before we start? Comments, concern, complaint, anything? No? And yes, I do have your exam, the makeup one. I'm going to give you when more people come. Today, you're going to fill out a reflection. It was actually mixed reaction for me. Some people did exactly same thing in the first exam, so their score did not change. Some people did worse. For example, I forgot your name. What is your name?
Who are you pointing at? That's a better question.
You. Jason.
There we go.
He got 93 in the first one, but in this one, he got lower because his exponentials are bad. But his math were excellent. The math portion was great, but exponent rules, for some people, exponent rules saved you guys. For others, exponent rule ruined you guys. So I don't know what's going on in this class. For some people, you guys know your exponent rules very well, but you don't know how to do math. And for others, you are doing math really great, but you know what is exponentials. So why? So you should figure out why. If you know one thing, but if you don't know the other thing, why is that? You know that you need to know the exponent rules in order to do your math. Especially chapter 10 is based on exponent rules, all the exponent rules. Okay. So, like I said before, whatever we have radical, we call that either radical sign or index, or if you write it in exponent form, we call them exponent or power. And whatever is inside the radical, we call them radicand. So if it's inside the radical, we call them radicand. But if you write it using a power, we call them base. What is square root of -1? I, because it doesn't exist. What about my pen? It's called I because we cannot find any number when you square, it becomes -1. So square root of -1, it means find a number when you square, the answer is -1. So what number square going to give you -1? We don't know. It doesn't exist in the real life. So it's I. On the other hand, if you have a negative in front of you, radical sign, it's a multiplication. So what is negative square root of 1? -1. Why do I have highlights? And then when you have the square root and square at the same time, it becomes 1. It becomes 1 if you have this scenario, when you have the square inside, then it's 1. But if you have square root of -1 squared, then it's -1. So this has two scenarios. If the square is inside, the answer is +1. But if the square is outside of the radical, the answer is -1. And then we went over some examples based on exponent rules. What is square root of 0? 0. What is square root of 36? 6. What is negative square root of 16/81? -4/9. You already have all of these in your notes. We went over this last class. So I'm going over them again real quick. And then negative based on inside or outside, we get two different answers. If you have a negative square root of 121, what's the answer? -11. Because negative in the front means it's a multiplication. So the sign stays. However, if the negative is inside the parentheses, because of the negative, it turns into I, and 121 is 11. So it's 11I. Well, let me show you the steps. It's square root of 121 and square root of -1. Because -1 times 121 is -121. This gives us +11, it's real number, but this is unreal, this gives us I. So the answer is 11I. What is square root of -11 squared? What is inside, the square or the square root? The square is inside, right? So what's the answer? +11. If your square is inside, the answer is +11. If the square root is inside, the answer will be negative. And then we have double negative. One is inside, one is outside. -11. And there is one more we didn't go over. Let's say H. -121 square. -121. And then the square. In that case, what will be the answer? But because of the square will, if the square root is inside, the answer is negative. But if the square is inside, then it's positive. So here, this is inside, right? Inside the radical. On the other hand, this thing is inside and square is outside. So the answer is 121. Why? Because let me show you here why. -121 square. So this inside we know 11I, right? Because it doesn't exist. But what happens to the outside? Why? I'm doing something wrong, right? Oh, it's not, yeah, 121. Okay, I got it. So it's 11 squared and I squared. Why? The exponent rules. If you have multiple base, one power, you distribute the power. Like xy to the power n was x to the n, y to the n. We applied this rule here. 11 squared and I squared. What is 11 squared? 121. But what is I squared? I squared is -1, real number -1. So the answer is -121. See? So that's why if you have a radical inside and then the power outside, the answer is negative. But if the square is inside and outside is the radical, then the answer has to be positive.
Question on that. So that, like, isn't it 11, -11 times 11?
So we have square root of -11 times -11, which is positive 121.
Yes.
Let me make it smaller. And what is square root of 121? That's why. See, if you take the inside, we always have to take the inside first, always. So if you take the inside first, it becomes imaginary number. But if you imaginary number twice, it becomes a real number. On the other hand, negative square turns into positive. And when the square is the positive answer, the answer is positive. So when the square is inside, it makes things positive. But when the radical is inside and power is outside, the answer is negative. Okay. And then we did evaluating radicals just like normal. All you have to do is replace your x with the given number. So if you're finding f of 2, it means it's 3 times 2 plus 5. And then you simplify. So 6 plus 5, that gives us 11. And we don't know how to simplify 11, so leave it alone.
For the h, you can't you take I out?
Which one?
H.
So when you take the I out, you have to put the square. So I square. This is what I did here. The 121 gives you 11 and negative gives you I. But here is square outside. So it's 11 square and I square. 11 square give you 121.
Isn't it becomes just 11 because the square root is with the other one?
The inside is 11i.
The-
But the outside is a power. The inside turns into 11i. But what happened to the outside?
There's nothing.
Another power. So power rule says if you have more element inside of the base, distribute them. So this square goes to 11 and the square goes to I. So it's 11 square and I square. 11 square is 121. Oh no. What is I square? It's a real number -1. So that says -121. And then we have a cubic root, but the rules are same. All you have to do is replace and simplify. So this time you're finding f of -18. So cubic root of -18 minus 107. Cubic root of how much we have? -125. And cube root means you're looking for same number 3 times will turn into 125, -125. -5. So the cube root, cube part cancel out. The answer is -5. This one we could not do anything, not simplificable, but that one we could simplify. So anytime something is simplificable, you have to simplify. And then we learned how to simplify radical. So when we have even power, like x square root and square, they cancel out. The answer is x, but we have to guarantee that that x has to be a positive number. If it's negative number, then it's not true. So in order to guarantee that, we use the symbol absolute value. It means whatever the answer is, it has to be positive. Like this one. If this is negative, C square is inside outside the radical, the answer is positive 11. So if the square is inside, the outcome has to be positive. To ensure that we can use the symbol absolute value, usually people don't do that because we automatically assume it's positive. But for new learner, like you're learning it for the first time, you should know that absolute value should be there, but it's always there, but it's invisible. On the other hand, we don't have to put absolute value here because the outcome tells us automatically what the result is. The rule here we use is this one. Oh, I told you I'll put them in the review sheet, but I forgot. I'll do them in the review sheet again. So if you have square root and a power, the radical goes in the denominator, power goes in the numerator. So it's 12 divided by 2. And what is 12 divided by 2? 6. So it's automatically positive. Anytime you have something even many times, if you multiply them even many times, the answer is automatically positive. So you don't have to put absolute value because you already know the answer is definitely positive.
It's not like in a like it's that's bad for one of them.
Huh?
Like in a revolution, one of the questions forgot to combine it.
Combine what?
No, that's the minus.
Minus it?
Yeah.
Okay, try to the minus sign. Maybe I forgot. Do you remember which one?
The one where have like four standard forms and then four standard forms you choose for and then you got that silver.
Oh, in the review sheet. The old one or the new one? Which one you're talking about?
Yeah.
Exam 4? So I have a typo?
I don't know.
Yeah, the old one, I'm not sure. The new one I posted 2 days ago. So yeah, if you have a typo, just let me know. Email me, I'll fix it. Okay, so the same rule applies for any root. The next one is a cubic root. So our goal is to simplify that into something simpler. So since we have two things here, one is number and one is variable. So first step is separate them and then simplify them separately. For cube root, our goal is to find one number 3 times so that it turns into negative 64. Can you think of a number multiply 3 times, it becomes negative 64? Negative 4. So the cube root, cube power cancel out. And we get the simple negative 4. We do the variable same way. It's 9/3. The power divided by radical. And what is 9 divided by 3? 3. So we get x cubed. So cubic root of negative 64 times x to the 9 is just the simple term negative 4 x to the 3. But we will not be always so lucky. We may not get perfect number always, like the next one. 81 is not a perfect cube number, and x to the 14 is also not a perfect cube number. But the first step is same. We split them into 2 pieces. One is the number, one is a variable. And now since 81 is not a perfect cube number, so we factor it into its prime factorization. When you see 89, which two numbers comes in your mind? 9 and 9. But you're looking for same number 3 times. That means you have to split 9 more. What two numbers comes when you see 9? 3 and 3. So do you see same number at least 3 times? Which number? 3. So we put them together because we need them to be together. So 3 cube and 3. And then we put them under radical sign. Why you do that? Because our goal is to cancel the cube root with the cube power. So that the 81 simplified to 3 inside and 3 outside. We don't know what is cube root of 3, so we just leave it alone. But we do know after canceling the cube root with the cube power, we have a free 3. It's free. It can go anywhere. Same scenario is happening here. 14 is not divisible by 3. So we can split 14 into 12 and 2. Huh? 5 is divisible by 3. You're looking for something that is not divisible by 3 anymore. Like 2 is not divisible by 3 anymore. But 5 is divisible by 3. Not evenly, but still you can divide. So your goal is to split the power into something that is divisible by 3 and something that is not divisible by 3 at all. So 9 and 5 you cannot do because 5 is divisible by 3 at least once. But 2 is divisible by 2 is not divisible by 3. And then, so this is x to the 12 and x to the 2. See, we are using the exponent rules again. The exponent rule we are using is if you x to the m and x to the n, then says x to the m plus n. So we are using it in the reverse direction. We are given the sum, we split it into 2 pieces. Why? Because our goal is to simplify. So this becomes x to the 12 over 3, and this is not divisible by 3, so leave it alone. Now 3 goes to 12 how many times? 4. So it becomes x to the 4 and something that is not divisible by 3. If it's not divisible by the if you have a power that is not divisible by the radical, don't do anything, just leave them. Like here, don't write 2 over 3. It doesn't help. Just leave them alone. Why? Because our goal is to combine free with the free and inside the radical with inside the radical. We're going to put them together. So the final answer is 3x to the 4. They're outside the radical. And we have cube root of 3x squared. They're inside the radical. And I believe this is where we left in our last class, right? If I'm not wrong. So let me know once you are done, then I'm going to call one more page. Ready? Come on. Do you need more time, Chanel? Okay. So now you're going to multiply, divide. We do the same thing. You're going to multiply the number with the number. And if you have a variable, variable is a variable, and then simplify. And in multiplication, there is only one condition. As long as you have the same radical, you're allowed to multiply or divide. But to add and subtract, there are two conditions. You have to have the same radical and also same radicand. If you don't have the same thing, you cannot add, subtract. But for multiplication, only radical is fine, having the same radical. Okay, let me do it here, since you guys are too slow. Square root of 3 times square root of 12. Since we have the same radical, square root and square root, so we can multiply their inside. So, and they're positive. We get 3 times 12, which is 36. Oh, we did that, right? It's square root, not cube root. What is square root of 36? 6. So as long as the radicand is positive, you're allowed to multiply them. But if the radicand is negative, you cannot multiply them until you take out negative as I. For example, if you have negative square root of 3 times negative 12, now you cannot multiply. You have to write square root of 3I, because this turns into I, and this also turns into I, so 12I. So first you have to take your I out from the radical. And now 3 is positive, 12 is positive, you're going to multiply them. So we get square root of 36, I square. I times I will give you I square. What is square root of 36? And what is I square? Negative 1. So the answer is negative 6. Okay. Any question so far? No question? Done? So I'm going to flip twice because we already did that. And then we have fourth radical, fourth root. The same concept, fourth root, as long as these two are positive, we are allowed to multiply them. So fourth root of 2 times 8, that becomes fourth root of 16. Fourth root of 16, it means you're looking for same number 4 times turned into 16. Which number? 2. So the fourth root, fourth power cancel out, and the answer is positive 2. So it doesn't matter what type of radical you have. In multiplication or division, you're allowed to multiply their inside. For even radical, they have to be positive, the radicand. And once you multiply the inside, you have to simplify. Sometimes you have a perfect radical number like 16 or 36. Sometimes you don't have perfect number like 81. So that time you have to simplify by breaking into prime factorization. Now here cube root. Cube root is most flexible. It doesn't care about its radicand. It could be positive, it could be negative, it doesn't matter. So cube root doesn't give us any I. Only square root gives us I. So as long as we have the same radical, cube root, we are safe. So we can multiply their inside. We get cube root of negative 9 times 3. What is negative 9 times 3? Negative 27. Now, can you think of a number if you multiply 3 times, it becomes negative 27, negative 3. So cube root, cube power cancel out. The answer is 93. So all these examples have perfect radical number, but in the exam you're not going to have perfect radical number. You're going to have something that you have to break it down and then you can have a perfect radical number, like the one I did. Any question? Who is lost so far? Be honest. Is anybody lost? Confused? Really? No comments? Guess the division by yourself. Same rule. Like multiplication, you do the division. So try it by yourself. Who is that? Yeah. Liliana is here, Martin is here, Christopher is here, Axel here, Matthews here, Eliza here, Angel here, Handa here, Maria here, Ashley here, Axona. Axona is absent. Jason is here, Kathy is here, Asim is here, Kayla is here, Krishel is here, Calisius is here, Mariam is here, Kay is here, Chanel is here, Joseph is here, Jonathan is not here. Ready? Done? Are you done?
The God was inside and then just what else was still. It says that if it was the God inside, then
See the hint I gave you? If you have the same radical division, you can combine them. So we have square root of x to the 7 divided by x, square root of y square, and y to the 6. Or you don't even have to write twice. You can simply write once. And then just work with them separately. In division, what do you do with the powers? What from what? Bigger from smaller, right? No. Smaller from bigger, right? So 7 is bigger, so we are going to keep 7, subtract the 1 from the denominator. But for the y, which one is bigger? So we keep the 6 and subtract the 2 from the numerator. And we have the square root. So we have x to the 6 and y to the 4 square root. And then we separate x to the 6 over 2 and y to the 4 over 2. Or maybe I should write one more line. Never mind, I should write one more line. Yeah. This is square root of x to the 6 and square root of y to the 4.
Wait, sorry. So that's just x over 6 squared root or y to the 4th root?
Square root of y to the 4th. And then remember I said the radical and power, you cannot have them if they are simplicable. So you have to simplify. it's x to the 6/2 and y to the 4/2. 2 goes to 6 how many times? So we get x cubed, and 4 divided by 2 is y squared. Just little tiny thingy. But the answer is x cubed over y squared. So step 1, look at x and y separately under one big radical, simplify them under one big radical, and then split them so that you can have their individual power. Then you're allowed to split them because of the exponent rule. Previously, the rule was if you have x over y to the power n, it's x to the n over y to the n. Same rule apply if you have x over y and 1 over n. 1 over n means it's a radical. So it's x to the 1 over n, y to the 1 over n, which is same as square root of xy means square root of x over square root of y. See, one exponent rule, but you can write many different ways. But the rule is one rule. Split the power when you have multiplication or division. So all of these numbers are perfect numbers. And now we are going to work with non-perfect numbers. So we are starting 10.3. Oh, and I forgot to mention, if you missed any previous homework, you can do so even though the due date is past. I set the due date for all the homework and quizzes. Let me see. August 18. You cannot do anything after August 18. Our final exam will be August 14. So I want to give at least 2 days to you guys without any homework, just preparing for the final.
We're talking all the homework seen from the beginning or just from like.
If you missed anything from the beginning, yes, you can complete them before August 11. And for the rest of the homework, I have deadline. Like for chapter 10, the deadline is next week, Monday. And then the more we go, I set all the deadlines. But if you pass the deadline, don't worry, the last day to do anything is August 11th. After that, you cannot do anything. Even it doesn't matter how many times you beg me to open them, I will not open them. Okay? There is no point for you to do the homework or quizzes if you fail the final. Failing the final means failing the class. So you have at least Monday, Tuesday, Wednesday, yeah. So I want you to have at least 2 days just without any homework or anything, just preparing for the final. And our final exam will be Thursday, August 14. Okay, section 10.3. But any question on 10.1? Now, whatever we did 10.1, we're going to do the exact same thing in 10.3. The only difference is the numbers are not perfect. So since the numbers are not perfect, we have to split them. So you're going to have one number outside the radical and one number inside the radical. So 54 is 9 times 6, right? Now we split our radical. Square root of 9 is a perfect number 3. But do you know what is square root of 6? No, so leave it alone. So for a perfect radical number, we don't get anything inside the radical. But when you have something that is not perfect, we have something left over inside the radical. Okay? Same question, but cube root, Eliza. First of all, break down 54 using two numbers. What two numbers comes in front? 9 and 6. So you have to split it radical. Square root of 9 and square root of 6. So what is square root of 9? 3. And what is square root of 6? No idea. Not nothing, we have no idea. So you put them together. Nothing means doesn't exist. It does exist, right? We just don't know what it is. How about cube root? What you're looking for now? Same number how many times? 3 times. So 54 tells us 9 and 6, right? We know that. But none of them are twice. That means you have to split them more. 3, 3, 3, 2. My 3 looks so weird. It's 3, 3. So I broke down 54 into its prime factorization. Now do you see the same number 3 times? What number do you see 3 times? 3. So we are going to group them into one group. 3 times, and there is a single left over 2. So we are going to split our radical. Cube root of this and cube root of that. What happens to the cube root and cube power? Cancel out. So we get a free 3, and this is the leftover, so I bring it down. Now, if you don't understand this, we cannot go any further. So tell me honestly, who did not understand this so far? You need more time? Another one? Yes, we have plenty.
Those are probably more like some of the previous ones are
Which previous ones?
like the social law, the ones for.
Quotient like this?
Yeah.
Okay, we have more later. But this, who is lost now? Because if you don't understand this, there is no point for me to go further. Be honest, guys. This will be the final exam. So I want you to feel comfortable from the baby step. These are the baby steps, okay? The next steps are building on the baby steps. So tell me if you're lost in the baby step. Any brave person here who wants to tell me that they are lost? Nobody is lost? Are you guys sure? Positive? Not lying? You know, when I started teaching my first semester, I asked this question, like, did you guys understand? And nobody replied, like, nobody said they did not understand. So I was so happy, like, oh, I'm a great teacher. Everybody understood. Until I saw the results, the exam. I literally cried my first semester, seriously. Like, I was so disappointed. It's like, man, I would never believe any student when they say they understood everything. If it's a lie. Okay, try this too. If you understood, that means you can do this too by yourself. So go ahead. What type of predicate is that? Pronounce it. What's the name of the sequence in both? Oh, yeah. So you're looking for same number how many times? So breakdown kills so it's same number twice. That gives you same number twice. Behind the calculation. the power. And whatever lecture work inside of the But curious, right? Why did you switch the position? How is it? So we did, and that too is equal for square root ratio of the cycle.
I don't think so.
And then by the word switch. Did you figure out? Going it's a shot. Okay, so none of them is it twice, right? That means you have to break down more. Break down 6 more. We cannot not here. Break it down parts. 3 is for which. Break down 6 more. Which should not was 6?
Yeah.
And I'll do this in the difference. It's a potential. What are the No, it's not only this that working for
Put the four inside.
that's to get so it's a potential. Not so far. So one will always be outside the room. And one is inside the room. If you want to
So I did
okay, this square, right?
go to four.
This one, what's it? Okay. So, what do you? So fix the names and then things 4 and 2, but it is really small. So 2, 2, 2 becomes 2. Then how can you choose twice? But how do you fold? You're looking for same number 4 times. Right? It's a foot foot. Fourth root. Why do you use this square root? Fourth root means you're looking for same number of 4 times.
Oh, so just keep it. So
It's a 4, 2.
so
So you have 1, 2, 3, and what is the other one here, right? 1 is here, 2 is here, and 4 is here. So this 4 is 4. So we have 1, 2, 2, 2, 3, 2, 4, 2. So you're looking for same number 4 times. So
no,
oh, you're looking for same number 4 times. So which number is 4 times? 4 is 2, right? Because of my almighty thing. Yeah, root 3. Bunch of four. Is that square? You don't use the root. Yes. Just prove it the numbers. 2. But 4 is worse. That's what we are going to do. That is 2 if you come on. And what is extra? Left over. This is square root, this is cube root, this is fourth root. So it doesn't matter what the root you have, you're looking for a number greater than the cube root is for 3 times, square root for 2 times, fourth root for 4 times. So you can use the two separate. And then and it's been an hour. Four. Yeah. You're looking for same number twice, so you can read it number 3. Then we should just so you have 2 4 times and extra. So I don't see. Jannah, it's supposed to be more numbers, because laws are so. So anybody with another question? 15 times and yes. Two gets allowed, but the food is supposed to be. Okay, not bad. Points. To 4 groups, right? So you have to put inside. Like inside your the 12, many of you wrote 2 and 6, no problem. But you're looking for same number twice. That means you have to break down is 6 more, 23. So we see the same number twice here. So 2 square and 3. And then we split our radical. Square root, square root. Square root and square cancel out. We get a free 2. And this is the leftover 3. So it comes down. And you always have to write the whole number fast and then the radical. Now you're looking for same number 4 times. So 48, I noticed almost all of you started with 8 and 6. Right? 8 times 6 is 48.
Start with a first square. Like something square.
If you start with 4 and 3, your life is easy. But see, most of you did not see that.
Wait, 4 and what?
12. 12 is 4 times 3, right? So square root of 12 means square root of 4 and square root of 3. What is square root of 4? 2. And 3 doesn't have any perfect square. So the answer is this. So the idea is what you see at the beginning. If you see something already perfect, your life is easy. If you don't see already perfect, then your life is hard. So in 48, you don't see 16, you saw 8 and 6. No problem, you're looking for same number 4 times. So 48 is 4 and 2, this is 2 and 3. Unfortunately, we still don't see same thing 4 times. So you have to split more. And now we see 2 here, 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 and here. We see 2 4 times. So 2 4 times and the extra 3. So you have to split our radical, 4th root of this and 4th root of that. The 4th root, 4th power cancel out. We get a free 2. And this is not free, so it stays inside. But your life would have been easier if you started with this. 48 is 16 times 3. But if you start with 16, 16 is already has a perfect root. 4th root of 16 and 4th root of 3. 4th root of 16 is 2. Because 2, if you multiply 4 times, the answer is 16. So you could do this in 2 lines. Eliza?
So with the insights, the 4, there's a 4 left in there, so that just like checks out the 4.
4th root and 4, they are not same. 4th root, it means what number, if you multiply 4 times, the answer is 4.
So what happens to that?
It becomes 2 and 2. Because when it's 4, it looks useless. We are looking for same number 4 times. So we split 4 into 2 pieces, and that 2 piece and that other 2 pieces, now we do the same thing 4 times. So we combine them together into 1 piece. So like I said, it depends on how you start. If you start with 16 times 3, your life is easy because 4 root of 16 is 2. And this is just giving it down. Then think here, you said 4 and 3, square root of 4 is 2, I just bring it down. So if you don't see a perfect number, then you split and split and split until you don't have to split anymore. Now for variable, we already did that, already showed. We are looking for, the first step is if the power is divisible by the radical, then you just divide. So we have, never mind. We write 14 over 7 because it's divisible by 7. 7 goes to 14 how many times? Twice. So answer is x with the 2 power. But not always the power will be divisible by radical. For example, here. 10 is not divisible by 7, right? So you have 2 choices. Either you break it down into two pieces. One is divisible by 7 and one is not divisible by 7. So below 10, which number is divisible by 7? 7, right? Then how many is left? 3. Seventh root. 7th root, 7th power cancel out. What is left? Only x. And this is not reducible, so we just bring it down. We split it 10 into two pieces. One is divisible by the radical, one is not divisible by the radical. So it's 7 and 3. 7 plus 3 is 10, right? Why I didn't use 5 and 5? 5 is not divisible by 7. So there is no point of splitting them. So this is one way of doing it, split the power. Another way of doing it is this. You divide. 7 goes to 10 how many times? Only once, right? But we do have some remainder. How many remainder? 3. So this whole number goes outside as a power, and the remainder goes inside as a power of the radical. Okay, so you simply divide, and whatever the whole number, that's the power on the outside of the variable. And whatever is remainder, it's the power inside the radical for the variable. So whichever method is easier for you, you can use any method. Either you split them and then do cancellation, or you can simply divide and then put them into two pieces. Are you guys confused a little bit? Kind of. Now here comes the main question. In the final exam, they'll give you something like this, multiplication. So you're going to multiply and simplify. So cube root of 9 times 9 and cube root of x to the 5 times x to the 9. We have numbers and variables, so put numbers inside one radical, variables inside another radical. Now for numbers, we are looking for same number how many times? 3 times because we have cube root. That means we have to split this. 9 is what times what? So 3, 3, 3, 3. Do you see same number at least 3 times? What number you see? 3. So put them together in one group. 3 times. And there is one left over 3. And then I put the cube root on both. What happens to the cube root and cube power? They cancel out. So we get a single 3. And this is not simplificable. So we just carry it down next to the root 3. Now for numbers in multiplication, what do you do with the powers? So x to the what? 14. Now is 14 divisible by 3? No. So you have two choices. Either split them with something divisible by 3 or simply divide and then split them at the end. Which method do you want me to show you? The first one or the second one? First one? Okay.
Yeah.
So inside 14, what is the largest number that is divisible by 3? 12. So you split your 14 into two pieces. One is 12, then what should be the other power? 2. And then you write down your cube. Cube root of this, cube root of that. Now this one we know is x to the 12 divided by 3. So 3 goes to 12 how many times? 4 times. So this becomes x to the 4. And this is not divisible by 3, so you just bring it down. Cube root of x squared. And then we just make them to be friends. This 3 is free, and this x to the 4 is free. So you put them together outside of the radical. And this 3 is inside the radical, and this x squared is inside the radical. So you put them together inside the radical. So here, 3x to the 4 outside the radical, and inside the radical, the 3 and x squared. The simplified goes with simplified. The leftover number goes with the leftover variable.
Can you show the other?
Here. So let me do it here. We have 3x to the 14. So it's x to the 14 over 3. 3 goes to 14 4 times, which is 12, and we have remainder 2. Now this 4 goes outside of the radical as a power on x.
Is that always the case?
Always. The whole number will become the power on the outside of the radical. And this 2 becomes the power on the x inside the radical. Cube root.
Inside whatever the radical is.
Whatever the radical is, the cube root. We have cube root here. So if you have square root, it goes inside the square root. If you have cube root, it goes inside the cube root. If you have fourth root, it goes inside the fourth root. So it doesn't matter what is the radical, the remainder has to go back to inside the radical. And the whole number goes outside the radical. Any other question? There is a very high possibility of seeing this in the final exam. So try 4 questions by yourself. Let me write them down here. Cube root of 3x to the 7, cube root of 18x to the 9, and the other one is 48. Cube root? No, square root. Square root of 48, 593. 593. So 3 questions. Multiply, simplify, or simplify. And I'll give one of these and one of the square root of 3. So we'll see 2 of these in the exam. One is the multiplication and one is just simplifying. Wants to see the number how many times. Okay. Let me see this good until you see some kind of results. First step, first step. Now first goes inside one practice to show the variable is inside and itself. So this is good. Square the right students. And now you look at T and T. Which method is easier to do by splitting the power or dividing? Okay. So inside 30, what is the largest number that you can with? Four. Four. Just going to pieces. Excellent. Ready? Thank you.
That's the second one. It's the same stuff. Oh, wait, the second one is no.
Whichever one. The largest is second.
The second one is like multiply. Multiply and add to 1 to 25.
You.
Yeah, 7 is 9 or 4.
What is it? 7 and 9.
That's 16.
Okay. So inside 16, what is the largest number divisible by 3?
15.
It's 5 and 1. How are you doing this? 25, 5 and 2, and 5 and 5 and 4 and 1 targets. But this is 2, right? That's it.
I get it. Yes, I think that's.
We were here to split whatever is splitting. Whatever you can split.
Okay.
Five, 3. The same thing is doing outline here and then in the same thing. Same thing for each one of them. Yeah, I think. So there's it's one reasons. So you have 14, right? Reasons one. So one is the biggest number divisible by 3 in the huh? It's had 13. You know 13. So what is the largest number? So multiply by 2. Okay. So it is 3, right? So 1 to 12. That should be 12 and 1. Here to the highest class. Anything more? Connection. There is that secret. And that's the connection. The remainder goes to the power I have. Power of the people is x to the 1. Which is x to the 1. And we have so 0 times 6. Great. Whether you know what to say on that one. I think this one.
Okay.
Yeah.
We throw that. We can draw so much because it's X. Because X, there's no numbers, it's just X. They're all square, like don't you think it's square?
You don't people same number teacher. You don't see them. So until you see the same thing.
I don't know what she's saying, it's like a police officer, but it's a, like when it's square, break it down. But it's not square, stop.
Like, oh, 1, 2, five, 2, 5. Lots of like 2 times 1.
The number,
Yeah.
the number was the body outside of the bathroom.
4 you also have.
And Jannah is what? So which one's getting
So you see 2 twice and 2 twice. It's 2 times 2. Yeah, that's what I did. That's what yeah, but like I don't know this and then we have next one. No, this is not like that. I meant 2 times you see. So you see 2 twice. And you see another 2 twice, right? You see 2 twice and 2 twice. Right? You can say it's the same thing twice. Twice. And you see this? And the square root is about square root is about. So 2 times 2. 3, 2, 4. The 4 doesn't make sense.
We jinxed you with that one.
So inside 15, what is the largest number that is divisible by 3? 15. So you cannot write 4 and 12. Even 16, right? So 2 and 4 doesn't make sense.
Yeah.
You're looking for the biggest number divisible by 3.
So,
15 and 1. So 15 and 1.
Okay, so I did this, but I almost.
So you see 3 times, and then the larger one, 2 and 1, 2. So you multiply 2 times 2.
Oh, bro.
Welcome to it. So again, one of these, and this will be in the exam. In this exam, the upcoming one. So we do 25 times 10, and then x to the 5, x to the 8. Now you can multiply 25 and 10, but it doesn't help you. So instead, just split them. We have 5 and 5, 5 and 2. And we are looking for the same number how many times? 3 times, because we have cube roots. So put them together. 5, 3 times, and then extra 2. So we have cube root of this and cube root of that. Cube root, cube power cancel out. We left to it the single 5. And this is leftover. Now we have cube root of 5 plus 8, which is 14. So inside 14, the highest number is 12, that is divisible by 3. So if you want to do, you can do x to the 14 over 3, which is 4 remainder 2. Now this 4 is x to the 4, and this 2 is x squared inside the radical. So these two are free, and these two are not free. They're inside the radical. So you put them together. 5 x to the 4 inside the radical 2 x squared. Huh? 5 and 8 is 14, right? 13. My bad, my bad. Oh man. Thank you, thank you. So we have remainder 1. 5 and 8 is supposed to be odd number because one of them is odd. And what's wrong with me? So it's 4 remainder 1. The next one is same, it's too small. But you guys can see it, right? So 3 times 18 under the cube root. And x to the 7, x to the 9 under another cube root. Now instead of multiplying, we can simply split them. So 3 is 3 times 1, 18 is 3 times 6. But you're looking for same number 3 times, so you don't see them yet. So you have to split the 6 one more time. And now we see 3 times. So 3 times. And then we have leftover 2 and 1. So you multiply 2 times 1, you get 2. Cube root of this, cube root of that. Cube power, cube root cancel out. You get a single 3 with the leftover 2. For variable, it's 16, right? 9 plus 7, 16. So it means it's x to the 15 and x to the 1. So if you do this, 16 divided by 3, it's 5 with remainder 1. So x to the whole number 5 and x to the 1 inside the radical. So 3x to the 5, they are free outside the radical. Did I make a mistake? And 2 and x inside the radical. This is too big. So you multiply and then simplify the numbers individually and variable. The last one, we didn't have to multiply because they already multiplied for us. They're telling us just simplify. So again, based on what you see, either your life will be easy or your life will be hard. Okay. Now, if you notice, this is square root. Square root of 48. Square root of x to the 5, square root of y to the 9, square root of z cube. Now, since square root, so you're looking for same number twice, or a perfect square number. So your life will be easy if you can see that 48 is 16 times 3. So square root of 16 and square root of 3. Your life will be easy. But I see most of you did not do 16 and 3. You started with which two numbers? 12 and 4? Okay, no problem. 4 and 12. Fortunately, 4 is already square, perfect square number. So you can take perfect, you can leave it alone. This becomes 2. But 12 is not perfect square number. So you have to split 12 more. 4 and 3, if you can see 4 and 3, your life is easy. Because square root of 4 is a perfect square number. But square root of 3 is not, and it's not more breakable. So you just leave it alone. So from here we get 2. From this 4, we get another 2. And this is not simplificable. So we leave it. 16 and 3 is easy. We have 48 is square root of 16 times square root of 3. So it's 4 times 3. But if you don't see, no problem. Do whatever you can see, work with those, and at the end you multiply them. So you have 2 times radical 3. That gives you 4 radical 3. Always look for something that is perfect square number if you're working with square root. For 4, it's x to the 4 and x to the 1, right? 5 is 4 and 1. So square root of this, square root of that. For y is 8 and 1. So square root of this and square root of that. For z, it's square and 1. So square root of this square, square root of 1. Now square root means you're dividing by 2. So this is x squared, square root of x. If you divide it by 2, this is y to the 4, square root of y. Or do you want me to show you the division? Let me show you the division, why not? So this is 4 divided by 2. This is 8 divided by 2. And you have z, which is 2 divided by 2. So all these powers, you divide by 2. So you get x with the square root of x. Y to the 4 with the square root of y. Z with the 1 power with square root of z. So for each of them, you have something inside, something outside. So 1, 2, 3, 4. 4 things goes inside and 4 things go outside. 4 x squared y to the 4z. Then outside the radical. And inside the radical, we have 3x, y, z. So it doesn't matter how many variables or how many elements you have, you're going to do the exact same thing. For numbers, you're looking for same number radical many times. For variable, you're looking for the power. The power is divisible by radical up to here. Any question? So the left page and right page, you're going to see that again in the exam. Obviously, different numbers. Any questions so far? Now, division, I'm not going to give the question in the division, but this is from you whom I can quiz. Same thing what you did before. Previously you had one big one, and now you have 2, but it doesn't matter. As long as you have the same radical, you can combine the inside. You have 81 over 3, x to the negative 10, x to the 5, y squared, and y to the negative 7. And now you're going to imply your knowledge from before again. Don't do anything until you change all the negative sign into positive sign for the power. So bring this 10 on the denominator. Bring this y on the numerator because they have negative power. So don't work with negative power. First convert them into positive power and then simplify. On the other hand, 81 and 3. Can you divide 81 by 3? How many times? 27 times. So you have 27. X to the 10 goes on the denominator. Y squared stays. X to the 5 stay on the denominator. Y to the 7 goes on the numerator. And you have cube root of that. So these are like terms. These are like terms. So we had 27 y to the what power? 9 divided by x to the what power? 15. And now you're going to split them. Cube root of 27, cube root of y to the 9, and cube root of x to the 15. Can you rewrite 27 as something to the 3 power? 3. So it's 3 cube. Y 9 divided by 3. X is 15 divided by 3. Cube root, cube power cancel out. We have 3. Y to the which power? What power? 9 divided by 3 is 3. Divided by x to the 5. This will not be in the exam, but it will be in a quiz and homework. Question? Is it too much? What do you think?
What is the entire, teaching process? Whenever they put next one,
At least you get it, which is a good thing. Okay, one more question and then I'm going to give you exam back. Here. We have a polynomial instead of one element or 2 elements. So what do you observe here? Factorable. So what 2 factors we get from here? 2 numbers multiplied to 25 combined to 10. Minus 5 minus 5. Negative 5 times negative 5 is 25. And negative 5 minus 5 is 10, negative 10. So inside the square root, you have the same thing twice. So x minus 5 square. What is inside, the radical or the square? Square, right? Radical is the outside and square is inside the radical. So we can cancel them, but what's the rule? If inside you have a radical, if the power is inside the radical, the outcome has to be what? Definitely has to be positive. So in order to guarantee that x minus 5 is positive, we have to put your absolute value sign. And in the my method, if you don't put this absolute value sign, they'll mark you wrong. Because you have no idea what is x. And minus 5 is telling us it could be positive, could be negative, we don't know. Anytime the square is inside, the result has to be positive. But if the square root is inside, we don't know. It could be positive, it could be negative. Okay. So that's all for today. Let me give you an exam. Tomorrow we are going to do something totally different fast, like is the distance formula, is the midpoint formula. And then we are going to do 10.4 addition and subtraction. Multiplication. 10.5 I'm going to leave for now and then go to 10.6. And then 10.6 is solving. So definitely we're going to do addition, subtraction, multiplication tomorrow and 10.6, which is radical equation. So left to 10.5, we're going to do that after exam. So you have to do a reflection. This time reflection is 1 point. Let me